Hello everyone, welcome back to Advent of Code 2023. Today's video is mostly going to be about day 19, which is one I haven't done yet. It's the most recently released one. But yesterday's video about day 18 I did not finish because I spent forever stuck on something in part 1 and didn't get to part 2. So I thought I would review my solution to part 2, which, I mean, is fairly, I don't know, uninteresting in a way. Mostly, it involved deleting most of part 1. I had all these cool ideas for, like, making stuff a little more general with this, higher order type for a map parameterized by an applicative, so I could decide how to handle the color conflicts. But it turns out that wasn't what part 2 was about at all. Rather, part 2 was asking you to find the area of a polygon again. So I did look up what the smart kids used on day 10 to find the area of that polynomial. There's two formulas, I guess, slash theorems for calculating areas of polynomials that are relevant here. This isn't even really using the shoelace theorem. I don't know. This is a formula for computing the area of an arbitrary polynomial based on, given its vertices. You can look it up on Wikipedia. And here's another one you can look up on Wikipedia. I say here as if you could see my mouse, sorry. Which is kind of interesting. So this is given on the Wikipedia Pick's theorem, usually as a way, it's presented as a way to calculate the area of a polynomial when the polynomial's vertices all have integer coordinates. And the solution is like, the area is some function of both the number of points along the perimeter of the polynomial. So both the vertices and the number of integer points that the polynomial perimeter passes through between two vertices. And the number of interior points in the is it polynomial? Polygon. So the number of points that, I guess I can show you, right? Why am I trying to describe it out loud? What a weirdo. Here we go. So the green ones here are exterior points. They're on the boundary, and the red ones are interior points. And it says, you can calculate the area as the number of interior points plus half the boundary points minus 1. But you can do a little bit of algebra and solve for I given A. Because we need to know I. But we've computed A already using the first of those formulas that we saw here. We computed the area of this polynomial. So we can use the area and the number of boundary points, which is easy to calculate as well, to figure out the interior points, the number of interior points. And then we add the number of interior points to the boundary points, and that's like the volume of the trench in that problem. One thing I guess to note about polynomial area, I wrote this little determinant function, which is the same that everybody else wrote. The linear package, which is what provides V2, is like a linear algebra package. And I was like, there is definitely a determinant function in linear. And there is. But it actually was like, I don't know. This is easier to read than using the determinant. Because the det 2, the determinant of a 2x2 matrix, is the function in linear. It doesn't take, it takes, I don't know. I was just worried that I might accidentally, it takes a V2 of V2s to get the 2x2 matrix. And you want it in row major order, which I think means you're supposed to put both X's and then both Y's into the V2s. And so it ended up more difficult to read this and make sure I was calculating it correctly than it is to just write this, which is very self-evidently correct, assuming you know how to calculate the determinant of a matrix, or you've looked up the shoelace theorem. I spent quite a long time on this, by the way, because I misread the Wikipedia article and it wasn't clear that I was supposed to divide by 2. They say in one place you should divide by 2 and compute the sum of some stuff. And then they say, oh, and there's also this other method you can use that, here, I can open this, right? Can I? Oh, I already have it open. Okay. So here, the shoelace formula. The triangle formula is the base of the popular shoelace formula, which is a scheme that optimizes the calculation of the sum of the 2 by 2 determinants by hand. Blah, 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 right? And sometimes draw it like this. I'm like, oh, yeah. So I didn't notice the 2 here. I just was like, yeah, A equals, okay, got it. This is what I should compute. And up here, they're saying A is half the sum of all this stuff. And they're saying, oh, the shoelace formula is a different way to calculate this sum. But they don't mention, oh, yeah, you still have to divide by 2. Like, the formula clearly has a 2 here, so I should have noticed, but I didn't. So I spent more time typing div2 than I did, implementing the entire rest of all these stupid formulas. Because I was getting numbers that were too high for area, and I couldn't figure out why. It was because I hadn't divided by 2. So I deleted all this shit in part 1. And I changed my type a little bit as well, I think. Yeah. Since we never actually care about colors, I have a segment type, which is just like an order, but with only the direction of the int, throwing away the color. And then part 1 and part 2 both delegate to solve, just passing it a different way to convert an order into a segment. Part 2 does the kind of trivial conversion of the hex number into the 2 parts you're supposed to have. I had to change the parsing around slightly, but not important. And, with that, we have 19 coming up because we finished 18. And they added another little cute animation here for... These are the metal parts falling down here, I think, or something like that. After we got the lava here, so now we have to get the metal parts here. So I have read this problem statement and I have some thoughts, but we'll get to that. Day 19, aplenty. The elves of Gear Island are thankful for your help and send you on your way. They even have a hang glider that someone stole from Desert Island. Since you're already going that direction, it would help them a lot if you would use it to get down there and return it to them. As you reach the bottom of the relentless avalanche of machine parts, you discover that they're already forming a formidable heap. Don't worry, though. A group of elves is already here organizing the parts, and they have a system. To start, each part is rated in each of 4 categories. Extremely cool looking, musical, aerodynamic, and shiny, Xmas. Then, each part is sent through a series of workflows that will ultimately accept or reject the part. Each workflow has a name and contains a list of rules. Each rule specifies a condition and where to send the part if the condition is true. The first rule that matches the part being considered is applied immediately, and the part moves on to the destination described by the rule. The last rule in each workflow has no condition and always applies if reached. Yes. So consider this workflow, and it's just a bunch of gobbledygook. EX, braces, and then some stuff. It's named EX, so a workflow starts with its name, then a curly brace, then a sequence of condition workflow name pairs like this, separated by commas. And the last one is a... Oh, they're not just workflow names. So I guess this is like a resolution, right? This one says go to 1, this says go to 2. But this one says reject, and this one says accept. So these are possible destinations that you could go to. So there's a sequence of conditions followed by destinations, and then at the end, one destination with no condition. If a part is sent to another workflow, it immediately switches to the start of that workflow instead and never returns. So it's not like a function call, it's a state transition. If a part is accepted or rejected, it immediately stops any further processing. The system works, but it's not keeping up with the torrent of weird mental shapes. The elves ask if you can help sort a few parts and give you the list of workflows and some part ratings. So we get a bunch of workflows and a bunch of part thingy-jingies. Workflows followed by a blank line, then the ratings. All parts begin in the workflow named in. Okay, good to know. In this example, the 5 listed parts go, yeah, okay. Ultimately, 3 of the parts wind up getting accepted. So you're supposed to add up the 4 components of each item, each part that gets accepted. Right? Add together all the rating numbers for all the parts that get accepted. Yes. So, that seems straightforward enough to just, like, run the simulation. To just, like, do everything exactly the way they say to do it. No, like, clever algorithms. I wonder, though, like... The last day, and some of the previous ones, have me thinking some about recognizing more when the problem they're asking me to solve should be viewed as some more generally applicable mathematical thing, right? Yesterday, we were asked to find the area of a polygon, and I did some insane, like, you know, flood fill algorithm to find the edges of the polygon. And, you know, it works, but you might say, you know, mathematicians have figured out how to solve the area of a polygon. And so there might be some cool shortcut you could Google for that would be more efficient and easier. And so, you know, it would be nice to recognize when problems are part of this more general thing. So, like, what is this? What does this make you think of? To me, it makes me think of a deterministic finite automaton, right? Maybe? It's not quite like that, because it's not consuming part of its input, but like, I don't know. It's not really finite because the numbers could be arbitrarily large, but it's deterministic and it's an automaton, right? So it's a bit like a state machine, sort of. And the state machine that it's most like, I think, is a deterministic finite automaton. So, I don't know. Maybe there's some benefit to casting the puzzle as being of that type, and you could get a faster solution for it. I don't know. Maybe you could somehow build a better decision tree, you know, read through all these workflows, and I don't know, maybe find out that, you know, PX always, you know, if PX sends its maybe not in this example, but perhaps PX might say, you know, if M is greater than 2090, send it to lnx, and then lnx always checks immediately if, you know, M is greater than 1548, which will always be true if it came here from PX. And then maybe we could optimize PX to say, oh, if M is greater than 2090, don't send it to lnx, just send it to what lnx would send it to, and we could, like, skip that step. I mean, I don't think there's going to be a lot of value in that, but something I wanted to at least make sure I think about before I get started. That said, I think I'm going to get started and just do the dumb brute force thing of simulating the workflows exactly how the problem specifies and see how that turns out. So if we look at my input, you know, it's what? 579 workflows. That does seem like a lot. Okay. And then 200 parts. Huh. I mean, the obvious thing is to parse each workflow into some data structure. You know, a list of comparisons and then a default case or something. We don't even really need the default case. We can just have the last condition be one that's always true. You know, parse these things into some data type that's like either reject or accept or this or whatever, right? So, seems okay. You know, I don't know. I was going to say, like, this looks like something Lens could make a little bit easier because it writes field accessors, but that doesn't make any sense. It's very easy to access a field of a record. So, yeah. Okay. Well, let's just get started on defining some stuff that seems like it'll help. Let's define a part is a part of, what do they call these? Excellence. Well, they call it extremely cool looking, but I'll call it excellence. Musicality. Aerodynamism? Is that I'm turning all their adjectives into nouns. And shininess. I don't have a good reason for turning them all into nouns, but you can't stop me. I don't I don't know that I need anything. Actually, you know what? What's the deal with monofoldable? Where is this? It's in monotraversable. I don't know if I have that in my dependencies. But it's a monomorphic container that can be folded here. Okay, first, actually, why am I thinking about this? What made me think of monofoldable? I know one thing I'm going to want to do once I'm done running all the workflows is sum up all the attributes of the parts that passed. You know, you could write, like, score of part XMAS equals XMAS. But, like, boy, isn't this tedious? Couldn't the computer help with this? And foldable is a type class, for letting you treat the contents of a data structure as a list. You have a foldable of t's, and toList gives you a list of t's, and then you could just call sum on that list. The problem is foldable is for polymorphic types. Like if I said a part of A is a list of all these things that are A's, and I could write that, I guess. But we're only ever going to use parts of ints. I don't think there's any reason I'm going to want a part of something else. And so this wouldn't really be a very sensible type definition. It would just be a weird... I would get foldable, but in exchange, I would have to specify what type of part I'm referring to all the time. So, enter monofoldable. Monofoldable... I don't really know how to use this. I'm going to have to read the docs. But the idea is it's an equivalent of foldable for a monomorphic container, but it has to somehow specify like what values it's supposed to return to you, and I don't know how it does that. With foldable, it's easy. It's whatever's in the last type parameter. That's the only thing it could possibly return, because that's the type of toList. Yeah, so you have to instance element this, maybe? Yeah. There should be an associated type element somewhere. Okay, where is element? I see. So we would have to. It defines all the element types of various things. Out of curiosity. So, like, the type element for inset must be int, right? If we, like, go look here. Yeah. So we could do the same for our part. Say it's... Actually, I bet it can't derive... Can you derive monofoldable? Maybe you can't, in which case I'm not getting anything out of all this shit. Well, let's look at... Let's, like, look at monofoldable's instance for some specific type, shall we? Like, where's the monofoldable instance for insets? What does it do? Oh, yeah, it has to write all this shit. I'm not doing this. You can't derive it like you can foldable. Okay, fair enough. There's got to be a generic one, though, right? I'm curious. All right, let's see. If I look up generically... What instances does... No, I guess it would be generically... Yeah, there's not actually that many things you can derive via generically, huh? Okay. So I think you would have to write the monofoldable instance yourself. At which point, like, I'm just going to write myself instead the way to add things up. There you go. So that's an easy one. Score. Part int. We did it. Our first useful function. We probably don't need anything but show. Oh, hang on. My alarm is going off. I forgot. Okay. Nothing important. You needn't worry. What else was... Now I've been thinking about monofoldable so long, I've forgotten what the problem is. Okay, we need to define, like, a workflow, right? And to define a workflow, we need a way to define conditions. And to define a condition, we need a way to define, like, transitions, I guess? Data... Let's say outcome. It's either a final data verdict is accept or reject. Most languages, obviously, people are just going to use Booleans here, right? But I really think in Haskell you should use domain flavored types when you can. I don't know. It depends on the purpose of the code you're writing. There are lots of people who write advent code and they just want to write a short function that works with, as little overhead as possible, and that's fine. But that's not what I'm doing. I'm trying to define a domain model and so on. Anyway, so an outcome is either a final, where we decide the verdict, or a transition to label. I think it's fine to make label just a type alias instead of a new type. I don't know why we would need to make sure we don't mix up a label string with some other string. Or why would we need to give it any different type class instances? So type should be fine. I mean, I don't think I need the eq or ord instances for outcome, but just in case, for verdict, I imagine we'll want eq because it would be nice to, like, filter a list for verdicts which are equal to accept or something like that, right? Now we can say data. Now here's another. I'm faced with. Okay, so let's talk about a step. Is a step where we have some condition and then an outcome, right? Where we basically, a condition might be excellence is at least 100, and the outcome might be go to PNZ, right? That's what I intend for step to be. The problem is, this is fine. Like, this would be an okay type when we're, processing a workflow. We could pattern match on the conditions that the workflow has and look up like what indexed thing we're supposed to look at, and like then look at it and then come, whatever. You could do that. But it's kind of, I don't know. There was that other day where I stored like functions, but I pre-compiled. It was the day with the mirrors, right? I kind of, instead of storing like, oh, this is a horizontal mirror in the map or array or whatever it was, I just stored a function from direction to direction in the map. I like kind of compiled as I was parsing the I parsed the input data like into a data structure that just had a function in it. And I think that's kind of a nice thing to do, but it does, like, I'd love for this step, instead of a condition, to have like a function from part to int. And I could just like have it store excellence or have it store musicality or something. Like, not store a part's excellence, but store the function excellence, which, given a part, returns the excellence of that part. That's like a little bit harder to debug, though. How will I know I've parsed the input correctly? And this has me thinking about like I don't really know what any of this shit means, but I read about there's a book I read a few years ago by Sandy McGuire called Algebra Driven Design, which I thought was really cool, and I've never applied it once, but it like was a cool way to think about things. And I don't think we're going to be doing any algebra driven design today, but there's this thing called like initial and final encodings that it made me think of. So the idea, I think, is that there are lots of ways you can encode a function and or some data type or something like that. I don't actually know I've never read. Hopefully this doesn't just have a bunch of porn when I scroll down. I imagine it won't, but you never know. Browsing the internet live on camera. So you can, the basic link. Okay, so this is a way to store a list. It's kind of the obvious way to define a list in Haskell. And the idea is you can also encode a list as a function. This is like church encoding, which I don't quite remember how it works, but I think it's kind of like So this looks basically like a catamorphism for lists, which is basically foldar. If you look at this, you'll notice, wait a minute, this is the type of foldar. Except that it doesn't take a list as argument because it is itself the list. And the thing that algebra-driven design made me understand about this initial and final encode. So this is called an initial encoding, where you have like, or I think it is anyway. You have like a data structure that represents, the stuff that made you decide how to build this, kind of. And this is the final encoding, where at the end you just have a function. And you can kind of compile any initial encoding into a final encoding. So I think what it might be interesting to do today is... yes, they have basic idea. Okay, append. Why would you want to do this? Good question. Yeah, with the church encoded list, the time required to append one list to another doesn't depend on either list's length, so you don't like pay for, like, concatenation is sort of cheap, which is nice. But I thought it might be interesting, or I now think it might be interesting. What if I defined all this stuff as an initial encoding with like data structures to represent everything. And then rather than interpreting that final encoding, I compile it. Obviously, I don't mean like I'm going to emit x86 machine code or whatever, but I'm going to consume the list of workflows and produce a function. And that function will just take apart and produce accept or reject. And that way Haskell will know how all these things are linked, and maybe it finds optimizations I don't, but it also doesn't have to like ever do any pattern matching. It can just like call a function. It can do just indirection. So I think that sounds like a kind of cool way to do it. So maybe we'll do that today. So a step is a step of conditioned outcome. We haven't defined an outcome or a condition yet. Condition is what? I mean, let's make it actually final, right? It's a condition of... Is it going to be a long set of data structures to model the input with like no shortcuts? A condition takes a field and an op. Well, let's say it takes an accessor. Well, that's just the same thing. Why do I... What? Sure, it takes a field and an op and an int. Yes, I think that's all. So then we need a field. Now here, it would certainly be simpler and more efficient to just like, instead of storing a field, store a function from part to int. But I want an encoding that is completely like kind of higher level than that and more, what's the word for like, I mean, printable, right? But more explicit, I guess. Not because I think it necessarily makes a better final program, but because I want to play with this initial versus final encoding stuff. So a field is either excellence or musicality or aerodynamism or shininess. Do I need ORD? I don't think so. I shouldn't even need eq, honestly. This should derive show, of course. So should this. Let's not define instances that we don't think we'll need, huh? I don't think I'm going to need ord for either of these. I don't think I'm going to need eq for outcome. Why would I need eq? What was I doing? So we will want eq for verdict. So I think that's fine. Okay, so I have a condition. What are my ops? Data op, I guess would go here, is... Actually, what's my input have in it? We have less than... Actually, I should just consult the problem definition, right? I think all we get is less than and greater than, right? There aren't any equals in the problems in the workflow definition, probably. Yeah, the very first equals is down here. Okay. So op is... if I call it GT, I'll be overlapping with the one in ordering. All right, whatever. Greater or less. The int doesn't need to be modeled. It's already there. Outcome, yeah. So the last thing we need then is data. Well, is it the last one? I don't know. Workflow is a workflow of label and list of condition. Nope, list of step. And then finally a default outcome. So I think these are the types that we would want to use to model the the workflows that are given to us in the input. And my goal, I want copmile. I want a function called compile that takes a list of workflow and produces a function from part to verdict. So this will like there you could write this by just interpreting by taking a single part and stepping through all the workflow pieces. I don't quite know how what I'm proposing to do is different from that. But I think it is. Let's see. Well, we're going to want data map, of course. Lazy, please, because I will want a self-referential map, I think. Yeah. Compile is compile of flows is I want to do all this work before I get a part at all, right? That's why we're writing flows equals instead of flows part equals. I guess what I want to do is look up in. Yes, that makes sense. because in is the starting point for every set of workflows. And M is going to be a map that refers to the result of compiling itself, right? Refers to the result of compiling each of the workflows. So where M is m.from list of map compile workflow of flows, I think. And compile workflow of a workflow label steps outcome is, or default we should call this, is well, first of all, label. This is the key we're putting into the map. And we need a way to turn steps and default basically into a function, right? So that's some sort of fold over steps, right? Where we're composing functions in a way. Sure. What if I said fold R apply step or something like that, right? Apply compile step. Starting with compile condition. Okay, can I get like this indented a little bit less aggressively, please? Something like this. So we return the label, that's going to go into the map. And then we're going to compile each of the steps where the initial state, which is what we get at the end of the list, is going to be basically a go-to for the condition, right? So, I mean, it feels a little bit nerve-wracking doing all of this without like type checking anything yet. But I don't know. I mean, obviously it won't type check. Oh, default is like a special. Default is a reserved word. Call it fallback then. Okay. So now it's just mad that we haven't written all this other stuff, which, yes, fair enough. Oh, excuse me. Yeah, compile step, compile. Okay, so let's define compile. Why did I copy it if I wasn't going to paste it? Of compile condition. Oh, but fallback isn't a condition, it's an outcome. Of final result, we'll call it verdict. Finally, we can say it is, lambda, I'm going to say const verdict, right? If we've gotten to the point of an outcome, then we can just return a function that completely ignores its input and returns the verdict. I think that makes sense. What's the other outcome called? Transition label. Sure. Compile outcome of transition label is look up the function in the map of workflows, right? Is that type check at least? Yeah, I mean, compile step doesn't exist yet, but we could say compile step is undefined, and it type checks. So we're getting there. One step at a time. Compile step takes a step and a condition and an outcome. It takes more than that because we're folding it. So we'll have it take a next function, which is what it does if its step doesn't match. It is, let's say, go? I don't know. Probably okay. Where go of a part, I guess, if I have a condition. Well, hang on. This doesn't look right. I think you could do this, but it's not what I want to do. I think I want to compile the condition and pass it outcome and next, right? So let's try this again. Compile condition of cond out, and then pass it compile outcome of outcome, and then also pass it next. So the idea is that compiling a condition a condition will take as input a compiled condition will take as input a then and an else clause, basically, and will, when it gets those two, produce a function. Yeah, this makes sense to me. So we already have compile outcome. Now we just need compile condition, right? Compile condition takes a condition and a field and an op and a threshold, an amount. We'll say threshold. So what do we want compiling a field to mean? It might help to put some types on these. These internal functions, don't you think? Workflow is a function from workflow to part to verdict, I think. And compile outcome is a function from an outcome to part to verdict. So this part to verdict, like this is what we're building most of these things as, but not all of them, I think, right? Compile outcome is a function from... No, wait. I have two things called compile outcome. Oh, these are the same function. Right, okay. Good, got it. You can't trick me. Compile step is a function from step and... Oh, you know what? This part to verdict thing I should give a type to. I should name that. Type? What do they call this in the problem? Anything? It's sent to workflows, a system. Yeah, nothing that great. We'll just call it compiled workflow. I guess what I want to do is... Okay. So here, step doesn't just return a compiled workflow. It needs another compiled workflow, I think. Yeah. Is that right? I mean, so this is what the type I think step has. It takes a step, and a different function from a different compiled workflow, which is what to fall back to. I think that makes sense. Does this type check so far? Compile condition, if true, I want to call them then and else, but those are reserved, of course. Met failed. Okay, so this doesn't really type check correctly. Oh, of course. Compile workflow doesn't actually return a compiled workflow. It returns a pair. Okay. So this does all type check. So I was right about the type that compile step has. Good. Or, well, I guess compile condition... What type do you think compile condition has, I wonder? Condition and then two things and then anything. Yeah, sure. Very funny. Condition... And I think both of these are just compiled workflows, right? That makes sense to me. Yeah. Well, it says, sure, you can return whatever you want. Undefined is magic. But I think these are the types I want. So the idea is... we're going to actually have to mention a part at this point. We'll call it run instead of go. I don't have a good reason, but I don't have to. Where run of P is... Actually, let's say run of p where when if presuming meets meets p meets criterion is met of p, otherwise is failed of p. And then we just have to define what criterion is. And meet, I guess. I think meet is just going to be apply, like... Yeah, I guess so. So why don't I just name this something different? So I don't have to define that silly function. Acceptable is... Let's see. Our criteria have an operator and a threshold, so we obviously have to compile the op. Yeah, I mean, I guess we can say acceptable of p is compile field of... No? I don't want a p yet. Acceptable is... well, is get of p, where we'll have defined get as like compile field. Get p, check threshold. I don't know. Neat. There you go. I found a reason to use that name after all. And get is compile field of field, and threshold. No, threshold is just the int. That's fine. We can leave it as is. Meets is compile op of op, I think, right? So compile op, presumably, is going to return like either the function less than or the function greater than. And so if I use that infix style here, it'll be... I'm always nervous about using infix operators, as I've talked about, because I don't quite understand how they parse. I think I could actually, though, say, like, I could define an actual operator that's local, right? And then I could just do this, and it'll definitely be the right... Get p will be one argument, and threshold will be the other. Okay. So I think this is what I wanted compile condition to be. We'll define compile field here and compile op. Those are the only two things I still need, right? Yeah, this does type check. Good. What types do I think they should have? Compile field takes a, I assume, field and returns a function from part to int. And this is sort of easy. F is case F of excellence, excellence. What are the others? Musicality, aerodynamism, and oops. I already forgot the last one. Shininess. So I think that's all compile field is. And op. What type are we using it? We're using it as, it takes a function, it takes an op and returns a function from int to bool, right? No, it doesn't even return a part. An op, int, and int, bool. Compile op of, I call these greater and less, I think. Yes. Okay. So we no longer have any blank spaces in here. It's a long function, obviously, but it's composed of a lot of tiny functions. I don't think this is particularly difficult to read if that's, you know, if you're willing to actually read something that just barely fits on a screen. Doesn't quite fit on this screen, but it's a pretty narrow window. And really, like, the only reason that these are all like in one big block is because they all need to refer to this M. They could be top-level functions, except that one of them, this one, needs to look up labels. So, I mean, we could make some of these top-level, I guess. I don't think that makes them inherently easier to read. It just, like, encourages us to indent them less and put some white space between them. But I think this is fine to indicate that these are all internal to compile. And so ideally now, like, all of the overhead of using these types to represent, you know, the problem statement faithfully gets washed away when we call compile. And then we just have a function as efficient as Haskell can make it from, well, as efficient as GHC can make it, I guess, from part to verdict. I mean, there is, well, I was going to say that this map is, we're indirecting through a map, but we're not, are we? The map vanishes as well. Like, it'll exist. Will it? I don't think it will. I think the map is going to get wiped away when we're done compiling. That's kind of beautiful. Because the only time we refer to M is here when we're compiling. So while we compile, we'll look up the function for other states in this map, but then we won't have the map anymore in here. We'll just have what was at that value. The map will have disappeared. Yeah, that's pretty cool. I did that on purpose, but I forgot it was going to work out that way. Yeah, I like that. Now, obviously, like, I don't know. You could write this somehow to be faster if like the compiler had access to everything as literals and could do more inlining or whatever. But in terms of writing a function, I think this is about as efficient as we could make one, really. Unless we were going to, again, find some like more advanced way to understand the input and shortcut steps that we know won't be needed for some reason. Like the example I gave where px always sent to lnx. If px sent to lnx, the verdict was predetermined and we could just not even look at lnx. You know. Okay. But assuming none of that is being done, I'm happy with compile. I'm not winning any points for verbosity, but that's okay. Or for terseness. I'm winning lots of points for verbosity. And I think I want to write a parser now that takes... Well, I want to write two parsers. Right, one for workflows and one for parts. So let's get textfrag exaplicative, please. I think I probably do want the RE type this time. Maybe? I don't know. Maybe I don't need it. I probably don't. Because we'll just write both. We'll write a parser for input, and that'll refer to two other parsers, and then that's all fine, I guess. We want some for sure. What else do we need? We definitely need sim. We need... psim, I guess, for parsing the names of workflows. We're going to need to say, oh, it has to be a bunch of it has to be a bunch of alphanumeric. So here's actually, I could see myself easily making a mistake here. I could have said, oh, parse a bunch of stuff that is not a left brace, and then parse this, right? And that makes sense. Then I don't have to be specialized to this being alphanumeric, and okay, cool. However, oops, you might have some problems. I mean, I guess it would be fine. The rest of the parse would fail, but it would maybe try to parse new line as the name of a workflow here and see, it's a left brace. There's a new line. Okay, this is a workflow whose name is new line, right? And then it would try to parse this as a workflow and it would fail, so I guess we would be okay. But that's the kind of thing that it's like a little bit dangerous to play with, and I'd rather be explicit that workflows are only ever named with alphabetical characters, and don't you try to trick me by parsing them some other way. So some psim, do I need string? I don't think so. Well, sort of. Not really. Yeah, I guess since the parts are always given to us in XMAS order, I don't have to like pay attention to what character it is. I can just say, oh, there's going to be some letter and then an equal sign, and then a number and then a comma, basically, right? Yeah, I don't know, maybe this is all I need from Explicative today. Of course, from common, we're going to want decimal to parse the ints. Anything else? No. So what is our input then? It is I guess a list of workflows. Yeah, I don't want to compile as part of the input parsing step, because I'd like to be able to call prepare and like look at it and make sure it's the right data structure. Although It's just going to be a giant mess of text. How will I know? But I can at least say, oh yeah, one of these steps is right. So it's a list of workflow, please. No, it's not. Actually, we'll probably find data input today is an input of list of workflow and list of part. Import data maybe from the same import I write every damn day, where an input is some workflow and then an extra new line. Oh, it's an input of some workflow and some part, right? Yeah. Couldn't match type? What's wrong here? I understand workflow and part aren't defined, but that error isn't what I would expect from that. Yeah, a bunch of variable not in scope. I get that. Of course. The issue is this was supposed to be there. Okay, there we go. Workflow is what? How do you parse a workflow? I mean, it's a... You know what? Let me just grab all this shit, make a copy of it down here for a minute so that I have it nearby to refer to. So a workflow is a workflow of a label and then one of these. And then some stuff separated by commas, right? I guess I want step by sim comma. And then an outcome is the last thing. Like that. It's a little bit long, but I think that's okay. Multiple okay, yes, I know. I mean, fine. First of all, I don't need that one, but there you go. Honestly, I don't even need part. Just those will do. Let's say label is easy. It's just some psim is alpha, which I will need to import from data char. Part is the one you think I should work on next, huh? Because it's mentioned here. Well, fine. Part is sort of easier, really. Part is a left brace. Oh, you know what? Let's put God, I hate writing sim \n over and over. new line. So each workflow is ended by a new line. New line is just this. And the parts are all separated by new lines as well. So a part is part of that's annoying. Well, it's okay, whatever. I'm gonna have to write out all 4 fields manually, aren't I? Because I don't have a list of things. And maybe, like, remember there was that other time when we used applicative and traversable to parse? And I was able to just, like, say, replicate 5. Like, it was when we were doing that poker hands thing, right? I was able to not have to write out explicitly all 5 fields, but just say, no, whatever. Field, I guess. Ooh, wait a minute. If each of these has like 1 extra junk character right in front of the letter, right? A comma or one of these. So I could actually parse them all uniformly as, like, ignore 3 characters and then parse a number, right? That wouldn't be so bad. And I could even, if I really wanted to, at that point go back and make part polymorphic and make it applicative and traversable, and then I could just say, like, traverse part or something like that over parsing whatever. But I think this is fine. What I can do is field, like, this is a little annoying. But I mean, it's not that bad, right? Field is ignore 1 character, any sim. And then decimal. Oh no, it was supposed to be 3 useless characters, right? Okay, 3 any sim. I'm gonna need to replicate M from control monad, I assume. Need any sim, yes, that's true. Okay, so now we're finally done writing part. And it's back to reminding me about the stuff inside of workflows that I haven't finished parsing yet. That's an interesting suggested fix you have there. Don't think it's going to work today, but I guess since you don't know what type sepby has, it's a reasonable suggestion. Well, let's define sepby first then. P sepby sep is... We've written this a million times, so it's this. P some. I guess I don't need that parent. Sep followed by P, right? Yeah, so now it no longer, I think, It no longer. Oh, it does say. Oh, maybe you could use step. Okay. Now it doesn't say that for outcome, even though I think outcome is a type. Oh, but it's not a constructor. That's true. All right. So let's find an outcome next, maybe. An outcome is a verdict, or did I import this? Of course not. Why would I be so thoughtful? A verdict or a transition. It's mirroring our type here quite closely on purpose. Verdict is accept of sim A, or and I think I need braces here, or parens here, or reject of, put the parens here as well, of sim R. Transition is, I think, just like it's just transition over, right? That's how we called it. Yeah, a label, which we've already defined somewhere, right? Yeah, it's a bunch of alphas. Okay. Something's wrong. My workflow doesn't have a close brace in it. Yep. That would have been an annoying mistake to track down. So we need step now, I guess. Is that the last thing I need, or type error? Oh no, couldn't match outcome with verdict. Oh. Outcome is verdict. Ah, final. Okay, got it. That's better. You know, I should actually just say, I think I should just inline that so that the two constructors for outcome are both in the same place. Is this really? Is this really parsing in the order I want it to? I'm nervous. Could it type check if it were wrong? Like, what if it were this? This won't type check, or well, this won't anyway, right? Yeah. So we can't parse it wrong in that way, and this is fine. I don't know. I'll put the parens in, same as I did down here. So what is a step then? A step is a condition, but I think we have to call step first, right? Step's a constructor, yeah. Step of a condition, an ignored colon, and then a label, right? Is that all? No, not a label, an outcome. Yes. Finally, a condition, I mean, not finally, there's a little bit more, is a condition of a field. Oh man, we still have to parse fields, okay. and an op. Oops. And an op and a decimal. Let's do op first. It's easy. Greater sim this or less of sim that. That's easy enough. Field is... Oh, I do need string after all. Or wait, no. It's just taking a single symbol, right? Yeah. I just have to parse this, basically. Okay. Field is... Do I use any sim here? I probably shouldn't, right? I should take a p sim of... Sure. Just say go over p sim of... Has to be one of the characters in Xmas, I guess. Where go... C is case C of X, excellence, M. Now this is a little annoying because this is a partial case match, but I know it'll be one of these four things, but I don't have a good way to prove that to the compiler, so it's going to warn me. Interesting. Shininess, come on. I mean, I guess instead I could... Instead of writing it this way, I could make it instead of psim, I could say it's a choice between these four parsers, and each parser would be total. Yeah, that is sort of better. A sum of zip width. Like that. Yeah, this is going to be way shorter too. No. Zip width, I don't know. Go. Of Xmas and where go of C and F is F in C. And we need to give this, actually, you know what, let's, well, enum and bound it as well. Because then instead of excellence, I can say min bound. Conflicting definitions for field. Oh, I have this twice. Let's replace this one with attribute, I guess. Can't make a derived instance of part. Oh, I put this on the wrong type. Okay, this is supposed to be show. this is supposed to have these things, enu and bounded. Oh, I want asum, I guess. Okay, now what? Line 88. SimC, please. Okay. Hey, type checks. So the parser's long, the compiler's long, but it's all going to be worth it because we had a good time. And I think it's sort of some beautiful theory. So let's try playing around with the REPL for the first time in ages. Let's suppose, first of all, let's find out if it type checks. Prepare of read file of input.txt. Nope. No parse. Well, fuck me. Am I missing new lines somewhere or what? I don't know. Oh, with all of these being private functions, it's impossible to test them independently. Well, that's easy to fix. Ta-da! They're all top-level functions now. Yeah, stuff shadows existing bindings. Get off my back, you nag. So let's try... matching, I don't know, what might be wrong. We'll bisect the problem. Workflow. Let's try parsing a workflow. How do I copy paste? Here we go. Yes, that parses. Great. Does it look correct? ZTJ says if shininess is less than 2703, then accept. If musicality is less than 1025, then go to VK. Otherwise, go to ZTL. Looks perfect. So what about parts? Can we handle that? Let's grab this one. That's not how you copy across tmux buffers. Gotta type that first. Okay. That parses also. Okay, that's great news because it means I just have some little missing punctuation in like how I combine these things, I guess. So this parses into, yeah, excellence, musicality, aerodynamism, and shininess. Perfect. That's exactly what we wanted. Okay. So what else is there that could be wrong? Huh. That is a little... It kind of looks like I'm only wrong on new lines, but clearly that's not the case. Braces? No. Because we parse workflows correctly. We parse parts correctly. Is it possible I fucked up my input by accidentally entering some weird character in here? I guess it's possible. I've made Emacs mistakes before. Typing a character when I meant to enter some, window change command. By the way, get rid of all these old days. Okay, great. So I guess just in case, I'll get my input back again. I sort of expected Emacs to say, hey, the file has changed on disk. But I guess it didn't because while the timestamp has changed, the content is the same, meaning no, my input file is not broken. So there is this one space where there's two new lines in a row, but that's on purpose, right? Workflows, each followed by a new line. Then one extra new line. And then parts followed by a new line. That makes sense. Oh, is label wrong somehow? Well, yeah, I guess there is sort of... This is an issue, isn't it? Like... Well, when you're parsing an outcome, you can't necessarily tell whether capital A is supposed to be a verdict or a label as written, right? I think it should parse the way we want because we happen to write verdict first, but that's quite delicate. I think we should actually change, and this won't fix our bug, like our current parse issue, but we should be more specific. It shouldn't just be is alpha. It should be like is lower or something. So what's in data char? So that is lower. Okay. Anyway, so instead of is alpha, we should have is lower. Like I said, I don't imagine this will fix things, but I will just in case test it and see. Yeah, still nothing. That's kind of annoying. What have I done wrong? It's like impossible to find out. I mean, okay. We could... I mean, I could parse multiple parts separated by new line, I guess. But this isn't really testing anything of my... I'm just testing that some and works, right? Like this, of course this works. What I want to know is like which one of these failed to parse. And I don't have that because I just have one giant regex that matches or doesn't match. I wonder if there's a workflow that doesn't have any conditions and just has a default. That wouldn't make much sense, right? But workflows label step by. So I'm requiring that there be at least one step, and then also that there be a default outcome. And I guess there could be some inputs that don't have that, right? I mean, like this one, I see some that have only one step and then an outcome. But I don't see any, and I wouldn't really expect to see any, but, you know, maybe, that don't have any steps. I guess that's the difference between set by and set by one, is that you don't require that any of them be met. And really, I've implemented set by one. I guess just in case, I should change set by to say, you know, it's this or and a match on that just gives you an empty list. Of course, that wasn't the issue as expected. Well, okay. Maybe what we can do is go get our input file, make a copy of it as input.test.txt, and just delete all but like 2 or 5 or something of the workflows, like this. And this way, I can test whether there's something wrong with how I'm parsing the file generally, or whether maybe there's one specific one that is in a format I didn't expect. Okay, there is something wrong generally. So what if I just did like this? There's just 2. That works. That doesn't work. Interesting. Why? So it doesn't expect there to be multiple workflows. Somehow it doesn't like them. And it's not like something about the order of these, right? Yeah, it hates these in either order. But if I delete either one of them... Oh no, hang on, what? It doesn't like this one all by itself, but it likes the ZTJ one? What? Did I just happen to get lucky and I found some workflows that it works on and some that it doesn't, and this is one it doesn't work on? Why not? What are you mad about here? Okay, well, this is good progress. Clearly, okay, well, so then we can ask, here's my equal tilde of workflow on this. Nothing. Okay, we've got it narrowed down to something. Okay, how about... Is this an acceptable label to you? Yes. And then there's a curly brace and some steps. What? Okay, well, what if I said parse this, I guess. I mean, I'm sort of at a loss for what could be wrong here. So some steps separated by commas here. We would want A3455A. And I think that's all, right? So this isn't parsing. Okay, Does step parse? I would think not if that other thing didn't, right? That did parse. So something's wrong with sep by, I think. Because isn't this one step? Did I write sep by wrong? Oh, I did. Okay, that's what I get for being lackadaisical about writing something I've written a million times, is I forgot. You are allowed to have... You don't have to have two, which have separated by. Many could be 0, but some is 1 or more. So I was failing to parse any workflow that happens to have only one step before the fallback. Now it's going to be just fine. Yes, okay. Yeah, now the whole input file parses. Okay. Fine. Where? Want to indent by what? 6? How do you do that? Not like that, but actually it's doing exactly what I wanted by accident? I didn't think this was right. Okay, I'm done. Oh, it was supposed to go even more, huh? Okay. I thought... Indent region... what am I missing? Okay, fine. Okay, and if I reload this, yeah, it still parses great. Okay, cool. So I guess what we could do now is say, like, you just write part 1, right? Part 1 of input of workflows and parts is sum of map score of filter equal accept dot run applied to parts, where run is compile of workflows. Yeah, type checks. So add up the scores of the things where having compiled the workflows, when you run it, it accepts, right? What do we get? What's the answer? Cool. A number. Is it plausible? Who knows? Let's put it in and see what happens. That's the right answer. Very nice. Well, let's get that committed, I guess. Anything I don't want to commit today? I imagine not. Yes, there is. There's those comments there. Okay, good. That's why we do these reviews. No. Okay, now I bet it's looking better, right? I mean, compile and prepare are the whole program. Oh, and these types are taking up a lot of space as well. But I don't know. I'm happy with it. Yeah. Day 19, part 1. Let's see what's up with part 2. Even with your help, the sorting process still isn't fast enough. I just saw a big number and I'm upset. What if the else comes up with a new plan? Rather than sort parts individually through all these workflows, maybe you can figure out in advance which combinations of ratings will be accepted or rejected. Yeah. Each of the 4 ratings have an integer value ranging from 1 to 4,000. Uh-huh. So we have to proceed backwards. Our compile function is no longer useful, I think. because we basically have to say, like, oh, this is gross. You have to look at all the steps that can accept or reject. And basically, if a step accepts, you have to look at all the ways something could get there. Like, if a step accepts with a condition, then you can say, okay, if you could get to this node or this step with that condition met, like, that would be valid. But for anything where the condition, where you could get here with the condition not met, then it isn't. Ugh. I don't know. I need a break and some time to think about this, and I don't know if I'll like actually put a live solution video up or just review my solution of part 2 like I did for yesterday's part 2 at the start of this video. We'll see. I'm happy with how part 1 went. Obviously, it wasn't like, the most challenging thing. It was just like apply the simulation rules. And I made it really, like, in some sense, harder than it had to be by doing this whole... I have 2 completely distinct ways to represent the problem and a compile step to go from one to the other. But I think it was instructive, I hope. And kind of based in sound theory, which is nice. Anyway, yeah, I'll think about part 2. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.